Hello everyone. Today we're going to be solving a system of three quadratic equations with quadratic terms, I mean. This can be interpreted as finding the intersection points of three spheres, one whose center coordinates are 3, 0, and 4, with a radius of 9. The other one whose center coordinates are 1, 2, and 3, with a radius of the square root of 72. And the third one whose center coordinates are 9, 6, and 4, with a radius of 3. So how do we go about doing this? Well, first of all, I want to expand on all three of these equations. So, instead of equation number 1, I'll just write it down as x squared. I'll be using the binomial theorem. X squared minus 6x plus 9 plus y squared plus z squared minus 8z plus 16 is equal to 81. Now, for the other one, we'll have that x squared minus 2x plus 1 plus y squared minus 4y plus 4 plus z squared minus 6z plus 9 is equal to 72. And for the third one, we'll have that x squared minus 18x plus 81 plus y squared minus 12y plus 36 plus z squared minus 8z plus 16 is equal to 9. Okay, underline it. Then I'm going to further rewrite this in a somewhat simpler form. So x squared, this is the first equation. This is this one rewritten. X squared plus y squared plus z squared is equal to 81 minus 9 minus 16 plus 6x plus 8z. Okay, so minus and plus 6x plus 6 and plus 8z. Or I can just rewrite that as 81 minus 9 minus 16. That's the same as 81 minus 25, which is the same as 56. So I'll rewrite this as, which is the same as 56. 56 plus 6x plus 8z. Okay? Now, let's just substitute this in to the other two equations. Okay? So I'm going to substitute that in here and into here. So instead of x squared plus y squared plus z squared, I'm going to write this here down. So 56 plus 6x plus 8z minus 2x plus 1 minus 4y plus 4 minus 6z plus 9 is equal to 72. And for the second one, I'll write it down as 56 plus 6x plus 8z minus 18x plus 81 minus 12y plus 36 minus 8z plus 16 is equal to 9. Okay, now again, underline it. And first I'm going to rewrite this one in a little bit of a simpler form. So I'm going to use colors. Let's first group the x's. Here's x, here's x. Okay, now let's group the z's. And finally, let's group the y's. And of course, we can also group these free numerals. Okay, once we've done that, we'll have 6x minus 2x, which is the same as 4x, minus 4y plus 2z is equal to, let's just go ahead and do this, 56 plus 1, which is the same as 57, plus 4, which is the same as 61, plus 9, which is equal to 70. Negate that, put it on the other side, and we'll just get 2. Okay, and let's go ahead and do something similar for the second one. Now here we've got 6x, here we've got minus 18x, no more x's. Okay, now let's go for the y's. Here's a y, no more y's. Now for the z's, 8z, negative 8z. And now let's go for the free numbers, 56 plus 81 plus 36 plus 16, and of course 9 over here. Now we can cancel out these z's right away, and what we are left with is 6x minus 18x, which is the same as minus 12x, minus 12y is equal to, so 56 plus 81, which is 137, plus 36 plus 16, which is 189, and minus this 9 here, so that's going to be the same as negative 189. Oh, sorry, negative 180. Okay, now we can divide the first equation by 2, and we'll get that 2x minus 2y plus z is equal to 2, and we can divide the second equation by negative 12, and that will give us that x plus y is equal to 15. Okay, from here we've got that y is equal to 15 minus x, and from here we've got that z is equal to 2 plus 2y minus 2x. Now let's go ahead and plug this into here so that we can get z as a function of x as well. So z is equal to 2 plus 2 times 15 minus x minus 2x. So z is equal to 2 plus 30 minus 2x minus 2x. Okay? Or in other words, z is equal to 32 minus 4x. Okay, now we've got that covered. Whoops, I made a slight mistake here. Here it's not 2, here it's 1 because we've divided by 2 already. So z is equal to 1 plus 2y minus 2x, and we have to correct them here as well. 1, 1, and here it's not going to be 32, it's going to be 31. So z is 31 minus 4x. Now that we know that, we can plug in these two expressions into our original equation, or any of them for that matter. All of them will give us the exact same solution. So I'm just going to rewrite that as x minus 3 squared plus y squared, which is the same as 15 minus x squared, plus z minus 4 squared, 31 minus 4x minus 4 squared is equal to 81. Okay? So we can just go ahead and rewrite this here part. Instead of 15 minus x, that's the same as x minus 15 because of the square here. And in the other one, 31 minus 4 is 27, so we'll get 27 minus 4x, which is the same as 4x minus 27. Why? Because we've got the square right here. Okay, so let's go ahead and expand this. So x squared minus 6x plus 9 plus x squared minus 30x plus 225 plus 16x squared minus 8 times 27. 8 times 27, that's minus 216x plus 27 squared plus 729 is equal to 81. Now let's go ahead and group this. So let's first group all of the squared terms. Now let's group all of the linear terms. And finally, let's group all of the free numerals. Okay, x squared. Now we can rewrite this as x squared plus x squared plus 16x squared, that's the same as 18x squared, minus 36x minus 216, which is the same as negative 252x. And here we've got 9 plus 225 plus 729 minus 81, which is the same as plus 882, which is the same as 0. Now we can divide both sides by the largest number that we can possibly do that with by the largest common denominator, which is 18, and we'll get that x squared minus 252 divided by 18 minus 14x plus 882 divided by 18 is equal to 49, which is the same as 0. So by using the quadratic formula, we can say that x1, 2 is equal to 14 plus minus 14 squared, which is 196, minus 4 times 49, which is the same as before, 196, over 2a, which is just 2. This cancels out, and we're left with 7. So the only solution to this system, the only in terms of x, is x equals 7. That's the first part of the answer. The second part of the answer, y is equal to 15 minus x, so that's 15 minus 7, which is 8. And z is equal to 31 minus 4x, that's 31 minus 28, which is the same as 3. So we will conclude by giving our answer also in a matrix form. So xyz is equal to 7, 8, 3. And that is our final answer to this problem. I hope you enjoyed the video. If so, please leave a thumbs up button and subscribe. I'll see you in the next one. Goodbye.